I'm Barry Maidment. I actually work for Rittal. I'm the product manager for the IT range. Rittal makes the physical infrastructure for the IT itself. So we make the enclosures, the actual central control units, the power modules, the crack systems, and the cooling systems that support that. So we actually make the physical walls here. Okay, that's our Lampert's room. That gives us the security, and then we actually move into the data center itself. Now what we're showing here is actually a cold aisle containment system. Now cold aisle containment effectively takes the traditional model of hot aisle and cold aisle and then makes it a lot more efficient. Now in the actual cold aisle containment, we actually put roof panels across the top, and we put doors on the end of the aisle, and what that effectively does, it traps the air in front of the server and creates a reservoir of air to allow the server to breathe, and then it exhausts the actual hot air from the actual return. Okay. From there, the devices that we actually use to create the cold air is actually either the crack system or what we call inline cooling. Now inline cooling is where we bring effectively a smaller crack system in line with the actual racks themselves, and we actually use a water cooled system, okay, that allows us to produce that air. The other option is actually the crack system, which is over here. The computer room air conditioning system, which is this device here, again effectively brings hot air from the actual servers through the roof, sucks it through a heat exchanger here, which then removes the heat and then blows the cold air underneath the floor, that is then re-delivered back in front of the servers. Now the whole idea of the cold aisle containment is to actually make the hot air coming into the crack system hotter. The hotter the better. So if we have this system here is actually a 49 kilowatt crack system. If I can increase the hot air temperature to this by another 5 degrees C, it turns the 49 kilowatt system into a 79 kilowatt system, therefore increasing the capacity. If I change the hot air return by another 5 degrees C, so I have what they call a 15 degree delta T, so effectively I have 30 degrees coming in at the top, 15 degrees at the bottom, the same crack system turns into 110 kilowatts, therefore it gives me a great deal more capacity, a lot more cooling capacity to actually deliver to the servers themselves. Okay, so that's where we have the actual system. On the outside, we actually have the chiller. The chiller is where we actually produce the cold water that is then delivered to the crack system and also the LCP. So the chiller system is here, and again that is situated outside, and using devices such as free cooling, we're able to actually reduce the overall efficiency down to around about 46%. So again, it just makes it a lot more efficient, and then the whole system is then actually tied in using a software package that makes the whole modules work together. So this is Rezone. If I actually go into the Rezone, I'll just show you some for example here, the UK views. We can actually look at the data centres we have over in the UK. So if let's go down to Plymouth, we can actually see a computer room down in Plymouth, which is seeing temperature. And again, if I go back into the UK here, I can actually then start going into Enfield, where we have a demonstration facility, and we can then start seeing what's going on inside here. So again, the whole system goes from the rack to the power to the cooling, and then pull it all together with actually the software to make it work a lot more efficiently. The event has been superb. We've got a lot of interest, and the quality of the people have been fantastic. So it was well worth it for us to attend. Our website is www.rittal.co.uk.